Here we go. Some of you, I see the familiar faces, so some of you already know TOPTEC and you know me personally, but those you don't, my name is Lédl and I'm in charge of the head of TOPTEC. So I just prepared a very short presentation about TOPTEC, and this is more or less focused on a space projects, because we do much wider field of the things, but today it is about the space, and I just have 10 minutes, so this will be only about the space stuff which we do. But I have to start a little bit with the information about TOPTEC, who we are. Well, TOPTEC is one of the application center of Czech Academy of Science, and we are really focused, or we aim to development of precision system or of precision optical elements. And we are located in Turnov, and it has some historical connotation. Why it is so? Because you may say, okay, where is Turnov actually? But most of you know, but it's not the center of the world. So why is it in a Turnov? But it has some connections in a history why it is so. So we have more than 60 years of history, and before that we were called the Optical Development Workshop, and some of you might also know it as Optical Development Workshop. But in recent years, we were fully equipped with the new equipment and apparatus and machines for the production of very precision optical systems. We do have approximately 50 researchers and 12 PhD and master students. This number, of course, is changing over the years, and we have a turnover of approximately 80 million crowns. However, it's difficult to talk about the turnover in some body like TOPTEC is a part of Czech Academy of Science. As I already mentioned, we are part of the Institute of Plasma Physics. So we have many projects with the universities and industry, and recently we were playing with the idea of setting up several spin-offs, because we do have a lot of technology. So my presentation today is more about the technology and about the development than the others. I suppose I just saw the two presentations, and they were mostly focused on science, so I'm a little bit focused on technology. So what do? We design optical systems, and those systems could be used in a hyperdimensional detection and spectroscopy, which is a very interesting field. Of course, we have to do the fine mechanics, and our specialty is aspherical and freeform optics. Maybe you know what the aspherical optics is, because it's quite common term today, but freeform optics is even more complex optical surface, which could solve a lot of different troubles. Of course, we need to do the thin layers, and just to measure something, because if we need to manufacture, if we need to produce something which is very precise, and we have to do it repeatably, of course we have to be able to measure precisely, and this is that's where the importance of ultra-precision measurement methods emerges. So the areas which we are active in, it's space, of course, that's why I'm here today, metrology, spectroscopy, high-power lasers, because you know that in the Czech Republic, even the Czech Republic is a small country, we have several laser centers, so we have to deal with power lasers or high-power lasers, and there is many companies also dealing with this field. And diagnostics, and of course in the Czech Republic it's quite difficult to avoid to automotive. Yeah, it's, you even you know you want or you don't want, you have to be sooner or later driven to this. So can you show me Jiří after 5 minutes or something like that? So about the several space projects which we have been involved to. So the first one, it's a very important project for the Czech Republic, and we were the lucky ones that we also had a part in it, and it's the most famous solar orbiter, because solar orbiter was a real big success of the Czech institutions, Czech companies, and we all together, like the Czech Republic, we had several apparatus. So we had the chance to be responsible for the delivery of the precisely manufactured mirrors, which were made from the Zero-Dur. You might know this material, and they were produced for extremely short UV, 121.6 nanometers. So also the surface quality had to be in connection to this number. Then we've several months ago, we finished the optical parts and mechanical parts and the whole optical system of the Aspix coronagraph, which will fly on the Proba 3 mission. So this is a much smaller system because those mirrors I talked about for solar orbiter, they were quite large, and 5 minutes. So I will speed up. So also interesting system. We delivered a lot of optical systems and measurement methods for the NEOSTEL project, which is aimed to the unveiling of the potentially dangerous asteroids. So we really delivered a lot of systems for collimation and stuff like that, and also the optical elements for this system. And then there is the Flex Flores, which we have just finished recently, and this was really big pain because it's very, very complex optical system with extremely great parameters, like an extreme levels of cleanness, and they are adjusted perfectly. So this was very, very difficult, and it is one of the most complex systems which we have ever developed. And we were responsible for theory study of a telescope for thermal IR. Now we have been working on Ariel optical bench, and Ariel is interesting because the telescope will have to work in 40 kelvins. So and the mirrors, because it's for IR, the mirrors are made from the aluminium, which is for space applications. But you know that with the decreasing temperatures, the materials might behave quite strangely. So we have to test it in 40 degrees, and it's a new challenge for us how to develop the testing benches that we could measure something in 40 kelvins. Finally, it seems to be that the material doesn't really, not so many problems. It's induced with the using of this material. So everything so far seems to be quite fine. But this cryogenic temperatures, it's really interesting. We are working right now, or we have been working on new polishing processes for freeform and aspherical elements for space. And we also opened recently the project for Truth and SBOTs, and also we cooperate with some company from Poland, which is called SAT Revolution, for the deployable telescope. The deployable telescopes, it's interesting field. We hope to have the chance to really develop the systems for the deployable telescopes. We have here the partners, Elia, and I hope others that we will be able to develop something like this concept, because it's really interesting. It could save a lot of mass. It could bring the really new interesting features. So this you see how our colleague Dr. Melich is playing with the final adjustments on the front end telescope for the Flex Flores. So that's one of the picture which looks nice. And well, what to say? We design, make, and deliver optical systems. And optical systems, they are really important for some space missions, for some observations, and so on. So it's important part. And we are here to tell you, to ensure you that we are able to do it, that we would like to cooperate, and that we are looking forward the cooperation and the shifting the Czech Republic from the maybe second level to the top level of the countries doing the great systems for space and other applications. Thank you very much.
Thank you very much. So there is time for some question. There are. Okay, I
no
asked,
questions. I ask always. No one really tends to ask me some questions, but well, maybe. That's great. That's great. Thank you. Thank you. Well, this has been quite big fine, quite big fight. Well, the head of like the director of our institute wants us to call it TOPTEC, but it's Turnov Optoelectronical Center, so it's TOPTEC. It makes sense to have the C there, but I hope probably we will go with TOPTEC. Yeah, and TOPTEC, it's more top technology. or TOPTEC is more top technology? What would you say?
So yes, so let's use TOPTEC because it's recorded and your director can see it.
He's such a nice person. He's a great guy, I have to say. No, I'm joking, of
my
course.
question is this, for the cryogenic temperature, do you have it in-house or are you using some external?
Well, because we have really smart guys and geeks, I have to say. They just came with the idea that they use some special pumps, cryogenic pumps from the vacuum coaters, so we could buy it for several $100,000 to really achieve something like, to reach something like minus 45 degrees, the 45 kelvins. So this was possible, but otherwise it would be very expensive. We have to have there several windows and so on. We had to construct and design and construct the apparatus which could measure inside. So we were mainly afraid of some sort of corrugation, some sort of warping of the surface if we produce it in some specification like the flatness and so on, that if you really cool it down to such a temperature that the residual stress in this material will cause warping and change of the shape of the material. But it doesn't seem to be the case. So that's the great message. So I hope it will be successful finally. Yeah. Okay. You are welcome. And
thank you all the speakers of this morning session again.